Have you ever thought about the discoveries that have reshaped our world as we know it? From breakthroughs that redefined medicine to insights that opened new windows to our universe, the 20th century was packed with game-changing scientific revelations. Curious about the discoveries that brought us into the modern age? Join us as we explore 8 remarkable scientific discoveries of the 20th century that changed everything, from our health and technology to our understanding of life itself. Penicillin, the accidental miracle. All right, picture this, it's the 1920s and even a tiny cut or scrape could lead to a life-threatening infection. That was reality before one incredible accident changed everything. In 1928, Scottish scientist Alexander Fleming was studying bacteria in his lab when he noticed something strange. A mold, just ordinary mold, had accidentally landed in one of his petri dishes. But here's the catch. The bacteria near the mold were completely wiped out. That mold was producing something powerful, which Fleming would soon call penicillin. This wasn't an instant breakthrough, though. Transforming penicillin into a usable drug took years of research and experimentation. But by World War II, it was saving lives on the battlefield, treating infected wounds that would have otherwise been deadly. Suddenly, medicine had an answer for infections, turning what used to be death sentences into easily treatable conditions. Imagine the relief of doctors and patients alike. This was a whole new world. The impact of penicillin went way beyond its immediate use. It opened the door to discovering other antibiotics, each developed to target different types of bacteria. Today, it remains a critical tool, though we've had to adapt, especially as bacteria become resistant over time. But still, Fleming's accidental miracle is a reminder that some of the biggest advances come from unexpected places. Who knew a bit of mold could lead to one of the most transformative discoveries in all of medicine? DNA, the code of life unveiled. Imagine cracking the code to what makes you, you. Back in the early 1950s, scientists were on a mission to understand the very blueprint of life itself. In 1953, 2 researchers, James Watson and Francis Crick, took a huge leap by discovering the double helix structure of DNA. This twisted ladder shape wasn't just a neat pattern, it was the key to understanding how genetic information is stored and passed down from generation to generation. Every little detail, from eye color to genetic disorders, is written in this microscopic code. But here's where it gets even cooler. DNA doesn't just store information, it can actually replicate itself. That's right. Each strand carries the power to make a copy of itself, which is why life can grow, repair, and adapt. With this discovery, science began to decode the very language of biology. And it didn't stop there. Understanding DNA opened up endless possibilities for medicine, agriculture, and even forensic science. Think about genetic testing, for example. Now we can identify risks for certain diseases, match organ donors, and even solve cold cases. DNA's role in everyday life has become monumental, and we're still finding new ways to use this knowledge. Thanks to this breakthrough, we're able to manipulate DNA to fight genetic disorders and develop personalized medicine that fits our unique genetic makeup. Watson and Crick's discovery was more than just a scientific win. It was a game changer that forever altered our understanding of life. We've only scratched the surface of what DNA can teach us, but one thing's clear, it's the ultimate blueprint of life. Quantum mechanics, unlocking the microscopic world. All right, let's dive into a world that's as strange as it is mind-blowing. The world of quantum mechanics. Imagine trying to understand how particles work on a microscopic level. Tiny particles like electrons and photons. In the early 20th century, scientists like Max Planck, Niels Bohr, and Albert Einstein started realizing that the rules of physics we know don't quite apply when you zoom in close. Instead, particles behave in ways that seem to defy logic. Take this. In the quantum world, particles can exist in multiple states at once, a phenomenon called superposition. It's like flipping a coin and having it be both heads and tails until you look at it. And then there's entanglement, where particles separated by huge distances can instantly affect each other. Einstein himself called this spooky action at a distance because it was so mind-bendingly weird. Quantum mechanics didn't just change our understanding of particles, it revolutionized technology. Without it, we wouldn't have things like lasers, MRI machines, or the foundations of modern computing. Quantum principles power the tech behind semiconductors, making computers and smartphones possible. Imagine that Our entire digital world stems from understanding the weird behavior of tiny particles. This field is still growing, especially with quantum computing on the horizon. Scientists are working to harness the power of superposition and entanglement to create computers far more powerful than anything we have today. Quantum mechanics might sound like a science fiction plot, but it's very real. And it's set to transform our future in ways we're only beginning to understand. Relativity, redefining time and space. Picture this, the fabric of time and space bending and stretching, almost like a cosmic rubber sheet. That's the idea behind Einstein's theory of relativity, which completely transformed how we see the universe. Back in the early 20th century, Einstein proposed that gravity isn't just a force pulling objects together. Instead, massive objects like planets and stars warp the space around them, creating what we perceive as gravity. It's mind-blowing. Now, relativity has two parts. First, there's special relativity, which tells us that the faster you move, the slower time passes for you. Yep, time actually slows down. If you were speeding near the speed of light, you'd age more slowly than someone standing still. Then we have general relativity, which expands this concept to include gravity. According to this theory, gravity can even bend light. So when you see distant stars twinkling, their light might be bending around massive objects along the way. This idea completely redefined how we understand space and time. They're not separate things, but interconnected in a fabric called space-time. This concept laid the foundation for modern astrophysics, helping us understand black holes, the Big Bang, and even the expansion of the universe. And here's something wild. GPS satellites need to account for relativity. Time moves slightly faster in space, so without adjustments, our GPS systems would go haywire. Relativity isn't just theory. It's essential to our tech and helps explain the vast, mysterious universe around us. Einstein's work reshaped science and will likely keep guiding us toward cosmic discoveries for decades to come. The Big Bang Theory, a glimpse into the universe's origins. Imagine the entire universe condensed into a single tiny point, a point so dense and so hot that it defies comprehension. That's where the Big Bang Theory comes in, giving us a glimpse into the origins of everything around us. According to this theory, about 13.8 billion years ago, that tiny point suddenly expanded, setting off a massive explosion that would eventually lead to galaxies, stars, planets, and, well, us. It wasn't a bang as in sound, but more like an intense, rapid expansion that set everything into motion. What's even wilder, the universe is still expanding. Scientists figured this out when they observed that galaxies are moving away from us, and the farther they are, the faster they're receding. It's like dots on a balloon being blown up. They all move away from each other as the balloon gets bigger. This discovery was one of the biggest game changers in astrophysics, leading us to the understanding that the universe has a dynamic past and isn't just a static, eternal space. The Big Bang Theory also gave rise to cosmic microwave background radiation, basically leftover heat from the universe's early days. By studying this ancient glow, scientists have gathered clues about the universe's infancy, and even the conditions that led to the formation of matter itself. So when you look up at the night sky, you're seeing galaxies that all started from a single point, connected by an ancient history that we're still uncovering. The Big Bang Theory doesn't just tell us where we came from, it opens up mind-bending possibilities about where we're headed as we journey deeper into the cosmos. Antibiotics beyond penicillin, expanding the arsenal against infection. Let's talk about the unsung heroes that took penicillin's place in the fight against infections. After the discovery of penicillin, scientists realized that this wasn't just a one-time miracle, it was the beginning of an entire field of antibiotic research. Penicillin was incredible, but it couldn't tackle every type of bacteria out there. So researchers began developing new antibiotics, each one designed to target specific infections that penicillin couldn't touch. Take streptomycin, for example. This antibiotic became a game-changer in the fight against tuberculosis, an infection that ravaged populations worldwide. Streptomycin showed us that antibiotics could be specialized tools, custom-built to attack different kinds of bacterial infections. Then came tetracycline, which opened up even more possibilities, treating a range of infections from acne to respiratory illnesses and becoming a staple in medicine cabinets around the world. And it didn't stop there. With antibiotics like vancomycin and ciprofloxacin, scientists kept pushing the boundaries, creating stronger, more targeted treatments as bacteria evolved and developed resistance. It's like an arms race where bacteria adapt and scientists respond with new weapons, staying one step ahead in this ongoing battle. These antibiotics, beyond just penicillin, expanded the medical arsenal and saved countless lives. They're the backbone of modern medicine, making everything from surgeries to routine infections far less dangerous. Without this growing family of antibiotics, healthcare as we know it would look a lot different. So here's to the power of scientific innovation in keeping us healthy and pushing forward in the battle against infection. Plate tectonics, explaining Earth's dynamic surface. Imagine Earth's surface as a giant puzzle, where each piece is constantly shifting. That's the idea behind plate tectonics, a revolutionary concept that changed how we see our planet. Before this theory, no one could explain why earthquakes happened or how mountains formed. But with plate tectonics, scientists realized the Earth's crust is divided into huge, rigid plates that float on molten rock beneath them, moving and interacting in mind-blowing ways. Now, these plates don't just sit still. They're in constant motion, driven by heat from Earth's core. Some plates pull apart, creating vast ocean ridges where new crust is formed, like the Atlantic Ocean getting wider every year. Others collide, forcing one plate beneath the other and forming mountains like the Himalayas. And when plates slide past each other, that's when earthquakes strike, releasing massive amounts of energy that can reshape entire landscapes in seconds. This theory explains everything from the creation of continents to volcanic eruptions. Before plate tectonics, we didn't really understand that Earth's surface is alive and evolving. It's like a giant conveyor belt, recycling crust back into the mantle in some places and forming new land in others. This concept turned geology on its head and gave us a deeper understanding of Earth's history and future. Plate tectonics isn't just about understanding natural disasters. It's a key to exploring Earth's geological past, from the shifting of ancient supercontinents to predicting future land formations. It's a dynamic vision of our planet, and it changed the way we understand the very ground beneath our feet. Insulin, a lifesaver for millions. Imagine being told that a diagnosis is essentially a life sentence. This was the reality for people with diabetes before the discovery of insulin. Back in the early 20th century, diabetes was a devastating condition with no real solution. But then came a breakthrough that would forever change lives. Insulin. Discovered by Dr. Frederick Banting and Charles Best in 1921, insulin became the lifeline that millions of people desperately needed. So how does insulin actually work? In simple terms, it's like the key that lets sugar move from your bloodstream into your cells, where it can be used for energy. Without insulin, blood sugar builds up and the body can't function properly. By figuring out how to extract and administer insulin, Banting and his team unlocked a way to manage diabetes, essentially giving people back their lives. The impact was immediate and profound. Before insulin, diabetes was often fatal. After insulin, patients who once faced inevitable decline were able to live full lives. Imagine the relief and hope it brought to families around the world. It was nothing short of miraculous. And what's even more amazing? Over the years, scientists have developed new forms of insulin and delivery methods, making treatment even more effective and accessible. Today, insulin remains a vital, life-sustaining treatment for millions of people with diabetes worldwide. It's a daily necessity for many, not just a medical breakthrough, but a life preserver. Insulin's discovery marked a turning point in medicine, reminding us that scientific advances can truly transform the world. These 8 discoveries didn't just change science. They reshaped our everyday lives and redefined what we thought was possible. If you enjoyed this journey through the 20th century's most remarkable breakthroughs, make sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay up to date with our latest videos. Until next time, keep exploring the wonders of science with us.